Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to talk about the distributive property, which is a really useful tool in algebra. And if you watched our video called the distributive property in arithmetic, then you already know the basics of how the distributive property works. The key idea is that the distributive property allows you to take a factor and distribute it to each member of a group of things that are being added or subtracted. Instead of multiplying the factor by the entire group as a whole, you can distribute it to be multiplied by each member of the group individually. And in that previous video, we saw how you could take a problem like 3 times the group, 4 plus 6, and simplify it two different ways. You could either simplify what was in the group first, or you could use the distributive property to distribute a copy of the factor 3 to each member of the group. And no matter which way you go, you get the same answer. But in algebra, things are a little more complicated because we aren't just working with known numbers. Algebra involves unknown values and variables, right? So in algebra, you might have an expression like this: 3 times the group x plus 6. In this expression, we don't know what value x is. It could be 4, like in the last expression, but it doesn't have to be. It could be any number at all. And since we don't know what it is, that means we can't simplify the group first in this case. Our only option here is to either leave the expression just like it is and not simplify it at all, or to use the distributive property to eliminate the group. Just like in the arithmetic video, we can distribute a copy of the 3 times to each member of the group, so the group goes away and we end up with 3 times x plus 3 times 6. The 3 times x can't be simplified any further because we still don't know what x is. But we can simplify 3 times 6 and just write 18. So the distributed form of this expression is 3x plus 18. And even though we can't simplify these expressions all the way down to a single numeric answer without knowing the value of x, we do know that these two forms of the expression are equivalent because they follow the distributive property. So the distributive property works exactly the same way whether you're working with numbers or variables. In fact, in algebra, you'll often see the distributive property shown like this: a times the group b plus c equals ab plus ac. Or you might see it with different letters like x, y, and z, but the pattern will be the same. This pattern is just telling you that these two forms are equivalent. In the first form, the factor a is being multiplied by the entire group. But in the second form, the factor a has been distributed, so it's being multiplied by each member of the group individually. And if you're looking at this thinking, what multiplication? Remember that multiplication is the default operation, which is why we don't have to show it in this pattern. Since the a is right next to the group, it means that it's being multiplied by the group. And on the other side, since the copies of the a are right next to the b and c, it means they're being multiplied also. And even though this pattern is usually shown with addition in the group, remember that it also works for subtraction, since subtraction is the same as negative addition. But the distributive property does not apply to group members that are being multiplied or divided. Okay, so this is the basic pattern of the distributive property. It's usually just shown with 2 members in the group, but remember that it works for groups of any size. We could have a times the group b plus c plus d, and the equivalent distributed form would be ab plus ac plus ad. Here's a few quick examples that have a combination of numbers and variables to help you see the patterns of the distributive property. 2 times the group x plus y plus z can be changed into the distributed form 2x plus 2y plus 2z. 10 times the group a minus b plus 4 can be changed into the distributed form 10a minus 10b plus 10 times 4, which is 40. And a times the group x minus y plus 2 can be changed into the distributed form ax minus ay plus a2, or 2a, which is more proper. So whether you're dealing with numbers or variables or both, the key concept is that the factor outside the group gets distributed to each term in the group. Each term in the group? But I thought terms were parts of polynomials. I thought we were way past all that by now. I was hoping you would notice that. And in fact, the members of these groups really are just simple terms in a polynomial. Well, that's what I'm here for, noticing things. Oh, a butterfly! Realizing that these groups of things being added or subtracted are really just polynomials will help you see why the distributive property is so useful in algebra. For example, in this simple expression, 2 times the group x plus y the x and the y are simple terms in the polynomial x plus y. Each of the terms has a variable part, but no number part. And if we apply the distributive property to the group, we get the equivalent form 2x plus 2y. But what if the polynomial was just a little bit more complicated, like this? 2 times the group, 3x plus 5y. In this expression, each of the terms in the polynomial does have a number part that is being multiplied by the variable part. But we can still use the distributive property to distribute a copy of the factor 2 to each term in the polynomial. Wait just a second here. I noticed earlier that you said that the distributive property does not work with members of a group that are being multiplied. And I also noticed that these terms do have multiplication. What's up with that? That's a good question. And it can be a little confusing to see how it all works at first. But notice that even though the terms do have multiplication in them, the terms themselves are being added. So we distribute a copy of the factor 2 to each whole term, but not to each part of a term. In other words, we treat each term in a polynomial as an individual member of the group, even if that term has multiplication going on inside of it, which is common since there's often a variable part and a number part being multiplied together. Getting back to our example, distributing the factor 2 to each term gives us 2 times 3x plus 2 times 5y. But this can be simplified even further because we know that 2 times 3 is just 6 and 2 times 5 is just 10. So the distributed form is 6x plus 10y. Let's try another example of a factor times a polynomial. 4 times the group x squared plus 3x minus 5. First, we need to identify the terms of this polynomial, so when we distribute the factor, we just make one copy of it for each term. This polynomial has 3 terms, x squared, positive 3x, and negative 5. So we distribute a copy of the factor 4 to each term, and we get 4 times x squared, or just 4x squared, 4 times 3x, which is 12x, since 4 times 3 is 12, and 4 times the negative 5, which is negative 20. So the equivalent distributive form is 4x squared plus 12x minus 20. Let's see another example. X times the group x squared minus 8x plus 2. In this expression, the factor being multiplied by the group is actually a variable, but the distributive property works exactly the same way. And it says that we can distribute that factor and multiply it by each term of the group individually. The first term is x squared, which is the same as x times x. So if we multiply that by x, we'll get x cubed, since that would be 3x's multiplied together. The next term is negative 8x. So if we multiply that by x, we'll have negative 8 times x, which is the same as negative 8x squared. Last of all, we have the term positive 2, and x times positive 2 is just 2x. So after distributing the factor x to each member of the original group, we have the polynomial x cubed minus 8x squared plus 2x. See why the distributive property is so handy in algebra? It shows us how to multiply a polynomial by a factor. We just distribute a copy of that factor to each of the polynomial's terms. So I know what you're thinking. If we can distribute something to each member of a group, can we do the process in reverse and undistribute something? We sure can. Take a look at this polynomial. 4x cubed plus 4x squared plus 4x. Notice that each term of this polynomial has a factor of 4 as its number part. In fact, it kind of looks like someone distributed a factor of 4 to each term. Since distributing a factor means making multiple copies of it for each member of a group, undistributing is going to mean consolidating multiple copies of a factor into a single copy that's multiplied by the whole group. So in this case, we can remove the factor of 4 that's being multiplied by each term individually, and then we can consolidate those into a single factor of 4 that's being multiplied by the entire polynomial by using parentheses to turn the polynomial into a group. But mathematicians usually don't call this undistributing a 4. Instead, they would say that we factored out a 4 from the polynomial. So you can use the distributive property both ways. If you get the expression a times the group b plus c, you can distribute a copy of the factor a to each member of the group. But if you're given the expression ab plus ac, you can apply the distributive property in reverse and factor out the a so that it's multiplied by the whole group at once. It's important to realize that neither of these changes the value of the expression. Distributing and undistributing a factor are just ways of going back and forth between two equivalent forms of an expression. And it works in cases where it's not quite so obvious too. For example, look at this polynomial, 8x plus 6y plus 4z. Notice that each of the number parts of this polynomial is an even number, which means it contains a factor of 2. 8 is 2 times 4, 6 is 2 times 3, and 4 is 2 times 2. So each of these terms has a common factor of 2, and that means that if we want to, we can factor out that 2. We can apply the distributive property in reverse. We remove the 2 from each term and consolidate it to form a single factor that's multiplied by the whole polynomial at once. And it works exactly the same way for variables too. What if we have the polynomial ax squared plus ax plus a? Each of these terms has the common factor a. So you could undistribute or factor out the a. Notice that when we do that to the last term, which was just a, that term becomes a 1, because there's always a factor of 1 being multiplied by any term. All right, so that's the basics of how the distributive property works in algebra. As you can see, it can get pretty complicated for big polynomials. But the most important thing is to understand how it works in simple cases so you can build on that understanding in the future. Being able to recognize the pattern of the distributive property and to apply it in both directions will allow you to rearrange algebraic expressions and equations when you need to. And remember, the key to really understanding math is to try working some practice problems so that you actually use what you've learned in this video. As always, thanks for watching Math Antics, and I'll see you next time.
Learn more at mathantics.com.